Using Green's theorem, evaluate integral over c 3x square minus 8y square into dx plus 4y minus 6xy into dy, where c is the boundary of the triangle formed by the lines x is equal to 0, y equal to 0 and x plus y equal to 1. Okay, so using Green's theorem, we want to evaluate this integral. Okay, so what is the given integral? Here the given integral is integral over c 3x square minus 8y square into dx plus 4y minus 6xy into dy. Okay, so using Green's theorem, we have to evaluate this integral. Okay, now I am going to write Green's theorem. Green's theorem. Integral over c u dx plus v dy is equal to double integral over r dou v by dou x minus dou u by dou y into dx dy. Okay, so this is Green's theorem. So using this theorem, we want to evaluate this integral. So now you comparing these two, dx coefficient is u, here dx coefficient is this. So what is u? By comparing these two, u is equal to 3x square minus 8y square. And comparing the coefficient of dy, v is equal to 4y minus 6xy. From the RHS, we want dou v by dou x and dou u by dou y. So what is dou u by dou y? With respect to y, it is 0 minus 16y. I want dou v by dou x. So dou v by dou x is equal to, it is 0 minus x differential 1 into this 6y. So here I am going to find dou v by dou x minus dou u by dou y. Dou v by dou x minus dou u by dou y. Dou v by dou x is minus 6y minus dou u by dou y is minus of minus plus 16y, which is equal to 10y. Okay, so dou v by dou x minus dou u by dou y is 10y. Okay, now you see, to evaluate this integral by using Green's theorem, it is enough to find only RHS of the Green's theorem, because the question is not a verification of Green's theorem. It is only using the Green's theorem we have to find out this value. So using Green's theorem means by comparing this, the required integral is LHS of the Green's theorem. To find LHS of the Green's theorem, it is enough to find only RHS. So using Green's theorem, it is enough to find only RHS of the Green's theorem. Okay, so for the RHS, I want this dou v by dou x minus dou v by dou y. So it is, we found minus, it is 10y. Okay, now I am going to find out RHS. Okay, so the Green's theorem is integral over c u dx plus v dy is equal to double integral over r dou v by dou x minus dou u by dou y into dx dy. Okay, now we know u. Already we found u value. The u value is 3x square minus 8y square into dx, and v value is 4y minus 6xy into dy. So we want to evaluate this integral. It is to find this, it is enough to find RHS. So that RHS is double integral over r dou v by dou x minus dou u by dou y. What is this dou v by dou x minus dou u by dou y? It is 10y. So 10y into dx dy. Okay, to evaluate this integral, I want to find out the limit. So what is the R region? Already in the question they are given the region R is bounded by the lines x is equal to 0, y is equal to 0 and x plus y equal to 1. So by using this I am going to form a triangle. Okay, so x is equal to 0 is y axis, y equal to 0 is the x axis, this is x is equal to 0, this is y equal to 0, and x plus y equal to 1 is, it is a straight line like this. This is straight line in intersect form, x plus y equal to 1. Okay, so this is our given region. Okay, now here the point of intersection R, this is the boundary, the point of intersection this and this. Here when y equal to 0, x value is 1, so 1 comma 0. When x is equal to 0, y value is 1. And this is not a point of intersection, boundary point, so this is origin 0 comma 0. Okay, now, so again I am going to apply the multiple integral formula method. Here I want to put either horizontal strip or vertical strip. If I put horizontal strip, x limit variable, y limit constant. If I put vertical limit, y limit variable, x limit constant. We can use any one. But here I am going to use horizontal strip. Okay, so put horizontal strip. So horizontal strip means x limit variable, y limit constant. The constant limit, y limit 0 to 1. So this is constant limit 0 to 1. Okay, now variable limit x is, the strip starts from the axis x value 0 to end with the straight line. From the straight line x is equal to 1 minus y. So this is the limit for the horizontal strip. So we can use this limit. Or otherwise you can put vertical strip also. For the vertical strip we will get some other limit. Okay, so now I am going to use this limit to evaluate this given this integral. Okay, what is the given integral? X limit is 0 to 1 minus y limit is 0 to 1, 10y dx dy. First integral with respect to x, because x is the variable limit. Okay, now integral 0 to 1, 10y dx integral is x. The limit is 0 to 1 minus y into dy. Okay, now we can substitute upper limit and lower limit now. Okay, substituting the upper limit, integral 0 to 1, 10y, substituting the upper limit 1 minus y, minus the lower limit 0, we can leave it, into dy. So here 10 take outside, integral 0 to 1, take y inside, y minus y square into dy. Now I am going to integrate 10 into, integration of y is y square by 2, y square is y cube by 3, limit 0 to 1. Okay, so 10 into 1 by 2 minus 1 by 3. So 10 into 3 minus 2 by 6. 3 minus 2, 1. So cancel this, 5 2s are 10, 3 2s are 6. So this is the answer of the problem.